Hello and welcome to the ELL lab project on the topic DC shunt motors. Myself Harshdeep Shakya and I'm a student of electrical engineering 2021-2025 batch, and in this project I will be discussing DC shunt motors. Let's start with the definition along with some basic details. A DC shunt motor, also known as a shunt wound DC motor, is a type of self-excited DC motor where the field windings are shunted to or are connected in a parallel to the armature winding of the motor. The circuit diagram for a DC shunt motor is shown alongside here. RSH is the field winding resistance, RA is the armature resistance, and its value is very small. The input voltage V is the voltage across both the resistances. IL is the current drawn from the supply, and it's divided into the two branches of armature and winding resistance. Next, we will discuss the working principle of DC shunt motors. The supply current in case of shunt wound DC motor is split up into two parts: IA flowing through the armature winding of resistance RA, and ISH flowing through the field winding of resistance RSH. The voltage across both windings remains the same. From here we can write the following equations, where I total equals to IA plus ISH and ISH equals to E divided by RSH, or IA equals to I total minus ISH equals to E divided by RA. Thus we put this value of armature current IA to get general voltage equation of a DC shunt motor. E equals to EB plus IA RA, or E equals to EB plus I total minus ISH into RA. Now in general practice, when the motor is in its running condition and the supply voltage is constant, and the shunt field current is given by ISH equals to E divided by RSH, which remains constant. But we know that ISH is directly proportional to phi, that is field flux, and it is proportional to field current ISH. Thus the field flux remains more or less constant, and for this reason a shunt wound DC motor is called a constant flux motor. Self-speed regulation. Initially considering the motor to be running under no load or lightly loaded condition at a speed of n revolutions per minute, on adding a load to the shaft, the motor does slow down initially, but this is where the concept of self-regulation comes into the picture. At the very onset of load introduction to a shunt wound DC motor, the speed definitely reduces, and along with same speed also reduces the back EMF EB. Since EB is directly proportional to N, given by EB equals to P psi Zn divided by 60, this reduction in the counter EMF for the back EMF EB results in the increase of the net voltage, as net voltage E net equals to E divided minus EB, since supply voltage E remains constant. As a result of this increased amount of net voltage, the armature current increases and consequently the torque increases. Since I is directly proportional to T, given by T equals to P into Z into psi into Ia divided by 2 pi A, this increase in the amount of torque increases the speed and thus compensating for the speed loss on loading. Thus the final speed characteristic of DC shunt motor looks like the graph shown on the right. Now let us discuss the construction of a DC motor. Construction of a DC motor is very similar to that of a normal DC motor and is shown in the figures given alongside, and the labeling is properly done for each of the figure, and it is shown for at different angles. However, the standard features of its construction are given as the armature winding must be exposed to an amount of current that's much higher than the field windings current. The torque is proportional to the armature current. The field winding must wound with many turns to increase the flux linkages. Flux linkage between the field and armature winding is also proportional to the torque, thereby increasing the efficiency of the DC motor. DC shunt motor has been designed in a way as to regulate the speed by itself on loading, and thus it's rightly called the constant flux or constant speed motor. Now let us discuss some applications of DC motor in modern world devices. Here are some devices along with the pictures, and also shown that the labeling. The devices are blowers and fans, centrifugal and reciprocating pumps, lathe machines, machine tools, and milling and drilling machines. Thanks for listening. This is it for my ELL project. The references used in the video in the presentation are given below.